Hello folks, well as promised we've got the customer's Amstrad 901. We did the 900 yesterday and this is an early one once again because we've got the old type of power socket which was already obsolete by December 1981. So you know the normal one is the square round one, and once again we'll use one of these connectors which Mr. Chippy has made up using mouldings, have been custom made for us by our friend Gareth in Leeds. So it connects up. So prior to that we had to make an adapter plate or get an adapter plate made and all that. So connect it to the test equipment. I think we'll open it up once again because we don't know when it was last used. I need to monitor. So the last one, the 900, we had to change the ballast resistor because there was no way we could get more than 3.2 watts out of it, and also the speaker was open circuit. So that surprised me, but I suppose it's not, rather than use, it's probably got damp and some kind of glue's gone hydroscopic and done that. I'm going to start it off at 9 volts, monitor it to a current limit of 300 milliamps. This looks absolutely fine underneath. I'm going to put the lid back. We'll put one screw back so the lid stays in place. And we'll plug in our standard replacement mic. These are Cybrnet wire because of Cybrnet radios. As I've said loads of times, the only Amstrad thing about these is the name on the front. Now that's got the bigger ballast resistor, though it is only 3 watt rated, but we may have a chance of getting 3.6. So if I can't get 3.6, we change the ballast resistor. Right, I'm going to switch it on, monitor. Alright, I'll just disconnect that. So while we've got no power, I've got half an hour at this point, so hopefully we can get most of it done. Well, that's in. Oh, power supply is on standby. Okay, so there we are, channel 21. Bit of dirt on the, nothing I'm going to do about that because it's self-wiping. So these the wafer for the channel display and the wafer for the doing the channel change are separate. Right, 13.8 volts, there we are. We'll get the clipboard at the ready. So one of the things about doing both these customer sets together, apart from the fact you're going to get them back quickly, is oh, I had to put speaker. Right, we're able to compare the two because they should be exactly the same. They're the same set, you just got the Roger bleep and those extra switches. Rumour has it that Mr. Sugar lost money on all the CB900s. He was hoping that everybody would buy the 901 because it cost very little more to put those features in. Right, picture in picture on, and we'll have the transmitter test set to its 3 watt range, so full scale deflection will be 3 watts. It's not quite 3 watts, it's 2.8. channel 1, 2.9 watts, channel 40, also 2.9 watts, that's unusual. Go to channel 20, non-adjustable low power, 210 milliwatts. We ended up with 500 milliwatts on low power on the last one, which isn't ideal. It's supposed to be 400 milliwatts. It's no longer important because that was to do with lowering the power by 10 decibel if your error was higher than 7 meters from local ground level, and that rule went in 1994, so that's not a problem. It was the CAA, it wasn't our government, it was the Civil Aviation Authority who got that low power thing. I've told that story many times before, so right. Transmit current on full power 1.327 is horrendous for that output. Okay, so we'll do the frequency, just see where that is. 2779084, 2779084, it should be 2779125. It probably won't make it to 125, but as long as it's over 100 we can let it go. It would have to be 027 or something like that, lower than that to be illegally low, and you'd have to be under this figure for it even to be noticeably low. Right, deviation on this test set, which we take with a pinch of salt, wallow, 1.7. Right, we'll dial in 2779084 into the signal generator. Oh yes, we will. 79084. We'll plug in. First of all, we're going to check PA with the speaker which is mounted on our wall. SW711 we use for the on the air tests, and we'll switch to Roger to that. Testing 1 2, testing 1 2, wallow. We've got a noisy volume control there, and these are of a type which are easy to clean. I don't clean these things willy-nilly because you're chasing out the lubricant. See whether that's helped. Testing 1 2, testing 1 2, 1 2. We have helped. Right, potentiometer, vol control, noisy, PA works. And when we were in transmit, what did the meter read? Let's go back to that and press the right button on the test set. It's full scale deflection, which is wrong. Doesn't have a meter lamp. The sockets work. So let's plug now our test equipment speaker into extension speaker. We'll need to provide an earth because we snip off the earth to our test equipment because of these modern sets with funny balanced outputs, which you end up shorting the amplifier out if you don't do this. I'll put it to that coil cam because we've done the transmitter. Wow, this is a jolly good receiver as well. I mean, they usually are, but this is better than the other one. This is component tolerances. It doesn't mean that all Amstrad 900s and all there's a big component tolerance. We've had Cybrnet sets only doing 1 microvolt and it isn't faulty. It's just at the less good end of the scale. Right, so we've got 0.23 microvolts for a kickoff. For 10 dB, got 0.2. For 20 dB, and of course this could be false if the detector's out. Squelch. Squelch to full. So I'll put the attenuator at what we're looking for is 100 microvolts for the squelch to open when it's set to full. So 3, 10, 30, it's coming in at 30. In fact, if we get a proper reading, yes it is 30. So 30 microvolts tight is too weak. Let's go the other way and switch the signal generator to standby. Turn the squelch down on the radio. Set threshold on the radio, signal generator back on. Straight in at 0.3. So 0.3 microvolts. Back to 100 microvolts signal, and let's see what the meter says. It should say S9. It actually reads plus 30. So full scale deflection once again. So we'll start with channel. Where's me? I've already forgotten what channel we do this on. I'm going to start with the VCO. It is channel 1, and we're looking for 2 volts. This is very important on this chassis. Go. Far side of resistor 6, capacitor 6 or whatever it is. 2.32. Let's see what it is on transmit. 1.92. So it's 2.32 plus 1.92. You're supposed to do receive first, and sometimes transmit, because they're interactive to some extent, will come right. So we'll just twiddle that, or try clockwise. That's fine, 2.02. Let's see what we've got on transmit now. 1.5, we're going to have to do that. So key the mic up. So 2 volts on transmit, back to receive, 2.02, back to transmit, 2 volts. Let's check what we've got on channel 40, 3.5 and 3.5, absolutely fine. So that needed doing, because transmit was probably going to start dropping out in different weather conditions. Right, let's see if there's anything we can do with this transmitter without changing the ballast resistor. If you ever come across these missing, always replace them. Some silly people think the radio does more power. In fact, it does it on a different frequency. Shown that loads of times. Radio shows on a cheap meter it's doing 7.5 watts. Put it on a spectrum analyzer, 2 watts are on 27 megs and 4 watts are on aircraft band. It's a real clever move, isn't it? I think we've done with that meter, so we'll put that away. Right, so I'm looking for the, I'm still on the 3 watt scale, I'm looking for the peak, maximum peak. I'm on the wrong channel, should be done on 20, try again. I want the centre of the peak, so I'm taking either way until I see that dip and that peak. We're now a whisker away from 3 watts. I think we're going to be doing another ballast resistor. That's alright, and then the power set on this one. Oh, that's gone well over. Let's go to the other scale now, see where we are. No, 3.2, just like the other. Turn the set off. I'll pop the mic off just to make it a bit more easy. Of course I did one yesterday, I might even remember where the part is. We'll take the sister flex off, put that on the new part. These are 6 watt rated. Scrape the legs in case, although we've not had them in stock that long. This is what all those dry joints are about in sets. Dirty component leads. Put the piece of sister flex back, and we'll have it a little bit higher in the mounting than it was before, so that it doesn't affect the capacitor there. Potential dry joint there, potential dry joint there, potential dry joint there, potential dry joint there, there, and there. Cut the excess off. Put the set back on. Right, microphone back. See what power we've got now. Oh, more than 4 watts, so we can drop that. There we are at 4 watts, and let's see what it is on the other channels. It was quite difficult to balance the previous one. 3.6, 5.3. So let's see. It's not that one causing it. It was one of the airspace coils in the in yesterday's. I'll just do that. Just see whether we can do the same. I think this could be our best compromise. 4 watts on channel 20. 4 watts on channel 40. 4.1 on channel 1. I don't like them to be that high. However, nobody's going to get prosecuted for that. 4.1, 4, 4. So, let's make sure that's sealed because they're easily shifted. Let's see what low power's now doing. So some of these coils were just slightly stretched and wanted compressing, and that one just wanted slight stretch. It's just the way it is. Oh, 390 milliwatts. That's brilliant. And so it's non-adjustable. Let's see what the current consumption is. That didn't happen. Let's try again. 1.229. 1.229. So once again we've gone up more than a watt, and it's drawing 100 milliamps less current because the internal SWR between the stages is now better. That's nice. See if we can do the frequency. So, frequency counter on the display. I can get it to 99. We'll come back to that later. You know, we can let it go. It's not off frequency, but if we start having to put crystals in, we have to use a scrap set to as a donor crystal. I buy them. You try buying them from China. 1 in 10 works how we want it to work. We can have them made custom in Belgium, £35 each plus post. You know, that's not going to fail in another 20 odd years, is it? No, Mr. Tango, it isn't. Right. So we'll just change the signal generator because I've now brought the frequency up a bit. Just so we're being absolutely fair. We need our earth lead on again. I'll just earth it to the body of the socket. If we stopped doing modern sets, I wouldn't have to faff about like this. Right, yesterday's the detector was out. Let's see what is happening today. Yeah, detector's out a little bit. Just set the other IF ones. The one down there. That one. That one. Drop the signal a bit. I'm showing you the wrong thing now. I want it on the SINAD meter. Do the front end. Spot on. Very, very slight adjustment there. Fine. Let's get a new reading. So we've got 0.27, .22 and 20. .52 the same. This is what happens when the detector's slightly out. You think, oh, that's really, really good, and then it's still really, really good, but not as really, really good as it was. But it's now not garbled. Unless you want everyone to sound like a Dalek. I wonder if that Roger Bleep works. Yep. Right, let's do the meter. So it doesn't want to be plus 30, it wants to be 9, not quite plus 30. And I need to recheck that when I've done the squelch. I didn't do that yesterday and it went out. I had to readjust it after the on-the-air test. So we're just not quite plus 30. When I increase the signal, we get plus 30. Right, let's do the squelch. Squelch to full. I think we'll do it. It's about 100 and... Let's just get you a figure. $135. I think we'll leave it there. And then the other side, let's just check we've got some decent sensitivity. Set the squelch threshold. Signal generator back on. Straight in at 0.3. We didn't do transmit meter. Turn the volume down. So transmit meter, I'll put the main meter back on the radio. We're still doing 4 watts. Yeah. Take the Roger Bleep off. Are we on low power? We are. Right. Meter is there. So it's supposed to be reading 4, and in low power you'd expect it to be 1. It is. There we go. So we've just got the deviation to do. I'll see whether the deviation meter behind me is ready. It's a 20-minute warm-up. It'll soon tell me if it isn't. Quick check. It's 1.6. So I said 1.7 on the other test set, so it's reading right today. That's it. Make sure that we've got a hiss with no signal if I turn the squelch down. Yep. Squelch control needs spraying. RF gain wants spraying. I don't know where this has been stored. Out of interest, we'll see what that says on this meter. Wall, wrong scale. Wall, it's exactly the same today. That's working spot on. Just put some switch cleaner on that one. And on that one, come back to it after an hour and we'll see where the frequency is. Right, an hour later, we'll just make sure this is somewhere near. Go to the frequency counter, see what we've got now. 2779107. That's very much near enough. So it's 2.2 to 2.5. It was 1.7. Let's look at these controls again. There's some noise even on the tone control. Let's see if we can get into that. Right, now for the moment of truth. Let's put the case back on. Seal the lid first, isn't it, on these? And of course, when we put the case on yesterday's, we found the speaker didn't work. These are two exceptionally good sets. And of course, the Amstrad 901, you can end up with the Hong Kong version or the fake version, and it's a different kettle of fish altogether. You know, you people would go, oh, they're crap Amstrad 901s, oh, they're crap, they are. And it turns out they've bought them for $29.99 brand new. Yeah. There's a difference between the $89.99 model like this and the $29.99 fake one. Let's switch it on before going to the bother of putting the screws in the case. Hey, the speaker works. Right, unplug it from the test gear. We'll switch the test gear off. Tomorrow we've got an emergency set. It's a realistic 1004. You don't see many of those. They're as good as it gets. They were a lot of money, like $149.99 for an emergency set. It's come body only, but they're as good as it gets. So, and they do at least have the LED display as well as just the rotary switch, because it can be awkward with those Midland ones, even though they work very well, and the Maxcom 4Es, which don't have the LED display. It's easy to get wear on the knob and not being on the right channel. So we'll do an on-the-air test of this, and then the customer can have these back. And where did the final screw go? It went there. He's the box he sent them in, he's kind of made boxes within the boxes. I've never seen anything like it. It's an absolute masterpiece. Compartmental boxes. Right, we'll put the aerial on the Antron 99 or Solarcon 99, whatever it is. One down a Roger. Oh well, there we are. A little bit of somebody a long way away. We're 35 miles from the nearest big town, so that's how it is. Right, well, thank you for watching the Amstrad CB901 genuine original immaculate condition set, now doing 4 watts and with receive at 0.27 microvolts for 10 decibel SINAD. There we go.